Okay. Hi, guys. Sorry I can't be there in person today, but hopefully I will be back at school tomorrow. Just as a heads up, your Unit 2 tests are graded, and you can see those grades in portals if you want to just see how you did. And I also updated your quiz grades as we did the unit before, so if you did better on your test, you'll see some extra points in there on your quizzes. You should be able to get those back maybe on Wednesday or Thursday this week. I still have a few people who have to take that test, and then I will get those back to you. But check in portals if you want to see how you did. Okay, we are starting our next unit today, and just a heads up, all of the definitions and everything from the previous 2 units we will continue to use in proofs and such, so keep those flashcards handy, keep studying those for a few minutes each night. All right, our next unit, we're going to focus on parallel lines. We did a lot with perpendicular lines in the last unit. Now we're going to look at parallel lines. I know you guys have talked about parallel lines plenty of times before, but just to get a definition here, I think you guys know that parallel lines are lines that don't ever intersect. But to write that definition in a geometry way, and just to practice, because this was another part people struggled with on the test, we're going to write this as a biconditional statement because it's a definition, right? So basically I can say that lines are parallel if and only if, and remember we can write that as IFF, the lines are coplanar and they never intersect. So the kind of new part for this, for our geometry definition, is that coplanar part, right? We've always known that lines or parallel lines are ones that don't intersect, but now we're going to say that they are coplanar lines that never intersect, meaning they lie in the same plane. In case you don't remember, there is a symbol for parallel. So if I have 2 lines, remember I can do the name of a line using a lowercase script letter. So if I have line L and then I have line M, I can say they're parallel by putting the true straight lines between them. And I always kind of make them a little bigger and slanted so that I don't confuse that with like an 11 or something. Okay, so draw ourselves a picture. I'm going to make a plane to show that my lines are in the same plane. Remember, a plane doesn't have edges, it goes on forever, but I draw it that way just so I can see it. And then I can draw 2 lines in that plane. There's one there, we'll call that line L. And then I can draw another one here, we'll call that line M. And those 2 lines would never intersect, so they are parallel. Also, one other thing, the way that we will mark this in our pictures, when we mark parallel, so if you remember congruent, we use like the little tick marks. For angles, we use the little arcs to show that they're congruent. So to show things are parallel, we'll actually put little arrows on the 2 lines. So if you see arrows like that on your lines, that signifies that they are parallel. Okay, and then we actually have another type of lines that don't intersect, and they are called skew lines. Skew lines, we'll do another biconditional statement here. So lines are skew if and only if, or 2 F's, the lines are non-coplanar and they never intersect. So the only difference in our definition there from parallel to skew is that planar versus non-coplanar. Or coplanar, sorry, versus non-coplanar. Okay? But don't be mistaken that if lines are skew, they are not parallel. They're very different things. Okay? They can't be parallel and skew. They have to be one or the other. Okay, so if I wanted to draw a picture of this, I'll draw myself a plane just like before. Search my plane. And I can put one line in here, maybe going like this. So that line is in that plane. So if I want to make a line that is skewed to that one, I need another line that is not in that plane and also doesn't intersect that line. So I'm going to make a line that goes through that plane, like from the top coming down through that plane. So the easiest way to draw that is I'll kind of give myself a little intersection point there, and I'll make my line go up that way. And then to go through the plane, remember if it's behind the plane, I can't actually see it. So I'm going to draw a dotted line to continue it through the back of the plane. And then when it comes out the other side, or on the bottom of that, it's going to be solid again. Right? So those would be skew lines. One line is in the plane, one's going through the plane, but they don't ever intersect. Okay, parallel and skew. One thing just to keep in mind here, this next sentence says, remember, segments and rays are parts, or they're contained in lines. They're parts of lines. So just because two segments don't intersect, that doesn't mean that their corresponding lines are parallel. So here's what I mean by that. If I draw these two segments, say, we'll make segment AB here. And then I'm going to make segment CD like this. Right? Now, if I look at those two segments, they do not intersect, right? But if I'm going to talk about the lines that kind of go along with these segments, if I extend this line off this way, right, and I create this as a line, and then I extend this line out this way, then those lines intersect, right? So just because the segments are parallel doesn't mean that the corresponding lines, or I'm sorry, just because the segments don't intersect doesn't mean that their corresponding lines are parallel. When we talk about parallel, we're talking about lines, not segments. Okay. Okay. We can also have parallel planes. So we've got lines that are parallel. We can also have planes that are parallel. So to show this, I'm going to throw in a little color here. So I'm going to do the bottom of my rectangular prism here, and I'm going to call that plane X, and then color in, maybe, there it goes, change my color slowly. Let's see, the top of my rectangular prism up here, and I'll call that plane Y. Oops. Make that a big Y though. It's okay. Okay. Those two planes are parallel, right? I lost my highlighter. There it goes. Because those two planes, it's like the bottom of the prism and the top of the prism in the picture as we see it, they will never intersect, right? So I can say over here that plane X is parallel to plane Y, right? We can also say that planes are parallel to each other. A great example of parallel planes, if I'm thinking of like a room, the floor and the ceiling of a room are always going to be parallel planes. You can also think of walls in a room. They just have to be walls that are opposite each other, right? Not the walls that intersect. And last thing here about parallel, we can also say that a line is parallel to a plane. So if I pick a line, let's say I pick line EF up here on the top of my prism, right? So that line EF, that is parallel to plane X, right? It never intersects plane X, so it is parallel to it. I can also say, if I think of a different line, let's say I look at line FG, right? That's over here on this side. So FG never intersects plane X either. So it is parallel to plane X. Okay, so lines can be parallel to planes as well. Okay, there is one other type of line we're going to talk about and we'll use quite often over the next several units and through a lot of the rest of geometry, and that's called a transversal. Okay, a transversal is a line that intersects two or more coplanar lines in different points. Okay, so the transversal is a little different than parallel. It does actually intersect lines, but it intersects multiple lines. That's the key, is that it has to be a line that intersects two other lines in different points, right? Or two or more. So for instance, if I were to draw myself a couple lines over here, so let's see, here is, we'll call this line A, and then I'm going to call this line B, and then I'll call this one line C, right? So there I've got three lines, right? Just three random lines. And then I'm going to draw a transversal that intersects all three of those in different points. So if I draw a line like this, that line intersects each of those lines in different points. So that is called a transversal. Okay. That's what a transversal is. It transverses those three lines is one way to think about it and to remember. Okay, when we have a transversal, we kind of create some special angles on our transversal, and some of those angles have names. So we're going to look at those. First thing I want to point out is, or actually let's do this first. Let's number our angles so that they're a little bit easier to label here. So I'm going to call this angle 1, 2, 3, and 4. And we'll call these 5, 6, 7, and 8. So those are the angles that we're going to look at here, right? And then the first thing we kind of want to look at is the difference between interior and exterior angles. When I talk about interior angles versus exterior angles, I'm looking at what's the interior of my two lines. So if I'm looking at line H and line K, the interior line of those lines would be here, right? And then the exterior would be out here and out here. So when I'm talking about interior and exterior lines, that's what I mean by interior and exterior, is inside those two lines or outside those two lines. Okay, things being very slow to erase here. Okay, so if I want to name all of my interior angles, then I would have angle 3, angle 4, angle 5, and angle 6. Right? Those are all of the angles that are on the inside of line H and K. My exterior angles would be angle 1, angle 2, angle 7, and angle 8. All of those angles are on the exterior of lines H and K. Okay, and just by the way, also, when you're looking at this picture, right now I have my transversal is kind of going up and down and my two lines are going sideways. That picture I can also draw this way, right? I can make my two lines go that way and then my transversal go this way. And then I'm looking at the angles here and the angles here. But I still have this interior part and then these exterior parts out here. Okay, but that whole picture can be rotated to go the other direction, just a heads up. Okay, so then with our interior and exterior, we kind of add a couple adjectives onto those, and we get 4 other main types of angles that we're going to talk about when we see these pictures. First, we have alternate interior angles. So I know that they are interior, right? So they have to be either 3, 4, 5, and 6, but they are on alternate interior angles, so they are on alternate sides of our transversal. And all of these angles are going to be in pairs. So when I'm looking at alternate interior angles, I'm going to pick one of my interior angles. So let's say I pick number 3. Well, its alternate interior angle would be on the other side of the transversal, but still on the interior. So it's going to be angle 6. So my alternate interior angles could be angle 3 and angle 6. And there's another pair of alternate interior angles, right? It would just be the ones on the other side. So I also have angle 4 and angle 5. Those are also a pair of alternate interior angles. Very similar to those, we also have alternate exterior angles. So if I can get a different color here, I can look at one of my exterior angles, say, oh, didn't change colors. There we go. Say angle 2, right? And that one is an alternate exterior angle. So I want another one on the exterior, but on the alternate side of the transversal. So that would go with angle 7. So angle 2, come on thing. Here we go. Okay, angle 2 and angle 7 are alternate exterior. And again, we have another pair. We can also do angle 1 and angle 8 are alternate exterior angles. Okay. Our next type of angle here. Oh, and I was gonna, oops, highlight these so my colors match here. Sorry guys, my pen's just being really slow today. Maybe. Okay, so there's my alternate exterior. Come on. Okay, we'll go to our next color here. Okay, so the next type are same side interior. Again, should be pretty obvious from what they're called, right? They're on the interior and they're on the same side of our transversal this time. So if, for instance, I pick angle 4, because that's an interior angle, its same side interior angle would be angle 6, right? It's on the same side of the transversal and it's in the interior of our two lines. So then one pair of our same side interior would be angle 4 and angle 6. And the other pair of same side interior would be angle 3 and angle 5. Right? Those are both on the interior and they're on the same side of the transversal. Okay, then our last type of angles here. Get my color to change. Come on. Does not want to cooperate with me tonight, guys. I'm sorry. Come on. There we go. Okay, what color would we have left? We could do, come on colors, purple. So corresponding angles. If you think about the word corresponding, I kind of think of like they go together, but really in math, corresponding kind of means they're in the same place. So they're in the same position is how I think of corresponding. So a corresponding angle, for example, if I picked angle 1, the corresponding angle to that is angle 5, right? So it's kind of like looking at the top 4 angles and the bottom 4 angles and picking the one that's in the same position. So 1 is in the top left and 5 is also in the top left. So for one of our pairs of corresponding angles, we have angle 1 and angle 5. And then for this, we don't have just 2 pairs of corresponding, we have 4 pairs, because then I could also do angle 2 and angle 6. Those are both on the top right. I could do angle 3 and angle 7. Those are both on the bottom left. And then angle 4 and angle 8. Those are both on the bottom right. Okay, so there's our 4 types of angles that we're going to talk a lot about as we go through this unit. Okay, so a couple things, and this is kind of what you're going to see on your homework. So we'll kind of go through some examples here. These first couple are just kind of identifying, if I saw these pictures, which line would be the transversal. So remember, a transversal has to intersect 2 or more lines at different points, right? So intersect 2 or more lines in different points. For a reminder, that's our definition, right? So the first one, if I look at J, K, and L there, the only line that is intersecting more than one line is line L. So our transversal for this one would be line L, right? J and K only intersect line L. L is the only one that intersects 2 lines. Okay, our next picture, we've got J, K, and L. And this time, if I look at it, well, L intersects both J and K, sorry, and then J intersects, it's not changing color, both K and L. And then our last one here, K, intersects both J and L. So all three of those lines are transversals in that case because all of the lines intersect the other lines in different points. Right? So all are transversals. And then our last picture over here, well, all three lines intersect, but they all intersect in just that one same point. Remember, part of our definition is they have to intersect in different points. So on this one, none are transversals. Okay, so here's what you're going to practice a lot of on your homework and what we need to get good at. And this is looking at this picture. We've got several different lines going on here, several different lines that can be transversals. And then I'm going to give you an angle pair, and we need to be able to decide if I look at those two angles, what's the transversal, what are the two lines that the transversal is going through, and then what type of angles are they. Okay, so here's where I think it's helpful to kind of either have different color highlighters, or sometimes you can just use different symbols if you're using pen or a pencil to where you can make marks and then erase them each time you do this. So one way to do this is, okay, my first pair is I'm looking at angle 11 and angle 1. So I'm just going to go in and circle my two angles so it's easy to kind of see where they are positioned on my picture. And again, another way to do this, if you don't want to do the circles, because you want to be able to erase those, is that you can use different color highlighter. So let's say I'm looking at angle 11 and angle 1. You can use the highlighter instead. Okay, I think it's easiest to pick out the transversal first. And the easiest way to name your transversal is you're looking for which line do both of those angles touch, in other words. Kind of think of that as in quotes, right? Or basically which line makes up part of that angle. So if I'm looking at angle 1 and angle 11, this line here, line C, touches both of those angles, right? So that means that our transversal is line C. Okay, then our two lines are the other two lines. I erase that. Are the other two lines that make up the other part of our angle. So to make up the other angle, if I've got line C already, then I also need line A and line B, right? So C goes through here as my transversal, A would make up that other part of my angle, and B would make up that part of my angle 1. Another way, let's see if I can get another way to see this. Just being slow to erase. Let's use a different color. So I can kind of outline the angles instead of highlighting them. So I could say, well, angle 11 kind of goes this way, and angle 1 goes this way. So you can kind of draw the angles on there like that and see that, well, they both have part of line C, so that's my transversal, and then 11 uses A and 1 uses B. So those are my two lines, right? Okay, so then if I'm looking at those two angles, I want to know what type of angles those are. Well, if I'm looking at lines A and B, they're on the exterior of those lines, right? They are on the outside of those two lines, and they are on alternate sides of the transversal. So these are not in highlighter. These are alternate exterior angles. Okay, and I'm fine if you abbreviate those words, that's cool. Okay, let's try a couple more. So now we're going to look at angle 3 and angle 6, right? So there's angle 3, there's angle 6. Okay, again, I'm looking for which line do both of those angles touch, right, for my transversal. And they both are a part of line A. And then the other two lines that make up those angles would be line C and D. And then if I look at those two angles, they are on the interior of lines C and D, and they're on alternate sides of A. So these would be alternate interior angles. Okay. And we'll go through a couple more here to try. So next I've got angle 9 and angle 8. Get my other ones to erase here. Okay, so angle 9 is here, angle 8 is here. Okay, now these two, I'm going to be careful because if I'm looking at those, I can look at the lines that make them up. They do not share a line, right? There's no line that they both touch. So 9 and 8 do not have a transversal. Keeps wanting me to write in the highlighter there. Come on. Okay, so those actually have none. And they don't have an angle type. If they're not on a transversal, then they're not one of our special angle types. Okay. All right, our next two is, let's see, angle 5 and angle 8. So we're keeping angle 8, but we're going to switch to angle 5. Oops. So there's our angle 8 again. We'll get rid of 9. And there's angle 5, right? I can't get that 9 to erase. Go away. Okay, well, we'll ignore the 9. So angle 8 and angle 5, the line that they both touch would be line B. So that is our transversal. Oh, this is driving me nuts. Sorry for all the extra commentary, guys. Okay, so their transversal is line B. And then the two lines that make up 5 and 8 would be line C and line D. And these two, one way to see these is they're on the same side of the transversal. So they're not alternate exterior, alternate interior, because they're on the same side. But one's on the interior of the lines and one's on the exterior. That's the easiest way to tell that we have corresponding angles here. So if you have one in the interior, one in the exterior, and they're both on the same side of the transversal, then those are corresponding angles. Okay, so ideally what I'd like you to do here is pause the video and try the last three. And I'm going to ask you a question. I think you'll go through and pick out one of them. But try those last three on your own and then come back and see if you get them right. Okay, so our last three, the answers for those, hopefully you tried them on your own. Angle 13 and angle 2, their transversal is line C. And then their two lines are A and B. And they are alternate interior lines, or angles, sorry. Then I've got angle 8 and angle 17. So we've got 8 and 17. Their transversal is also C, and their two lines are B and E. And 8 and 17 would be alternate exterior angles. And lastly, 1 and 19, their transversal is also C, and their lines are also B and E, and they are also alternate interior angles. Okay, so hopefully you did okay on those, and we're able to at least get parts of those correct. All right, last part of our notes here, we've got some true, false, and some lovely always, sometimes, never. This, again, was one of the parts of the test that I think a lot of people struggled on. Remember, when you're doing these, know why it's true or why it's false, not just that it's true or false. Okay, so just kind of reviewing some of our definitions we talked about in these notes. A transversal intersects only parallel lines. If we look back at the definition of transversal, it just says that it has to intersect two or more lines. It doesn't say anything about them having to be parallel. So that is false. It can intersect any types of lines. Just has to be coplanar lines. Next one, skew lines are not coplanar. That one is true. That is part of the definition of skew lines, is that they are not coplanar. Our next one says that if two lines are coplanar, then they are parallel. Well, not necessarily always true, right? That's a false. Our two lines could be coplanar and also intersect. And the last one, if two lines are parallel, then exactly one plane contains them. This phrase we've seen a few times before back in Unit 1, exactly one plane contains them. That basically means they are coplanar, right? It's basically saying they have to be in the same plane. And two lines to be parallel, that's part of our definition. They have to be coplanar. So this one is true. Okay, and some of our always, sometimes, never, same idea, but now we've got three choices. First one, two skew lines are parallel. Well, we said that at the beginning. Oh, sorry. Skew lines are not parallel. Those are two completely different definitions. So skew lines are never going to be parallel. Two parallel lines are coplanar. Parallel lines always have to be coplanar. That is part of our definition. So that would be always. Next one, a line in the plane of the ceiling and a line in the plane of the floor are parallel. Well, if I put a line across the top of the ceiling and I put a line across the floor, to start with, they're not in the same plane, but then I could create a plane that goes through those two lines, right? Unless I make one of those lines turn the other way, and then those lines would be skew. So this one would be sometimes. That one's a little bit harder to visualize. I'll kind of go through that one again when I get back, just to make sure that one makes sense. Two lines in the plane of the floor are skew. Well, this says right here in the plane of the floor, meaning the two lines are in the same plane, but the definition of skew says they have to be non-coplanar, so this would be never. If they're in the same plane, they can't be skew. Next one's kind of similar to our third one. A line in the plane of a wall and a line in the plane of the floor are parallel. Okay, well, they're in two different planes, so they could be skew lines, but I could make them in such a way that I could make a plane go through them, which means they could also be parallel. So this one is sometimes. And again, that one might be a little harder to visualize, so we'll come back to that one. Last two, a line in the plane of the wall and a line in the plane of the floor are intersecting. Well, if I kind of look at the wall and look at the floor, and if you imagine a line there, I could make them intersecting, or I could make them skew. So this one again would be sometimes. And our last one, a line in the plane of the wall and a line of the plane of the floor are skew. It's kind of the same thing as what we said above. They could either be intersecting or skew. So this one is also sometimes. Okay. If any of those don't make sense, put like a little star or highlight those and ask about them when I come back. We'll go over a couple of those if we need to better visualize those. Okay, that's our notes for today. You should now go and pick up a homework. It is all just a worksheet homework today. There's no book work to go with it. And you're doing kind of the same thing and naming the types of angles. The next part, you're naming the lines and the transversals. And the last kind of part there, you're picking, or again, naming the types of angles. And we got some always, sometimes, never for you guys to practice. Answers are at the end. As always, make sure you're questioning if you get your answer wrong, or if you got it right, make sure you know why it is that answer. If you don't know why, circle it and let me know, and we'll go over questions. All right, I hope to see you guys back on either Wednesday or Thursday. Have a good rest of your day.